Hey everyone, thanks for checking out the video for Wednesday, January 27th class on ratios, proportions, and similarity. I have my screen up on my Canvas calendar right now so you can see where you can find the notes that we will cover in class today. The practice, if you would like extra practice to prepare for the quiz on this lesson, which I will now mention, will be on Friday. So this is a policy change that's going into effect starting on Friday, where we now take quizzes in class. So as you can see, we will have our regular lesson with our notes, and then we will take our quiz. And if there is time permitting at that point, we can start working on the practice based on Friday's lesson. So quizzes will now be taken in class while we're on Zoom. So let's get started with that lesson. So our lesson today is on ratios, proportions, and similarity. By the end of the lesson today, we would like to be able to apply proportionality to determine if figures are similar. We will learn what that term proportionality means. We will write similarity statements and identify corresponding parts of similar figures. Okay, so what is a ratio? So first of all, a ratio is just a comparison of two numbers or quantities. And sometimes we have more. So sometimes we compare more than two numbers, but typically in this class it'll be two numbers. We can write a ratio as a fraction. That's what we'll do the most often in this class, in words, or using this symbol called a colon. Ratios can be simplified. So in the same way that we think of reducing a fraction, ratios can be simplified in that same way. So let's take a look at an example here. We're going to compare the number of trumpets to violins that this music store has in stock. They have 40 trumpets, 39 clarinets, 24 violins, 51 flutes, and 16 trombones in stock. So the number of trumpets is 40 to the number of violins, which is 24. So I'm using this method to represent my ratio. Both 40 and 24 can be reduced or simplified by the same number. That number is 8. So I can divide both the 40 and the 24 by 8, which would give me a reduced ratio, or 5 to 3. So this would be the final answer that we would want. Flutes to clarinets, I'm going to do using my fractional form. So 51 flutes to 39 clarinets would look like that if we expressed it as a fraction. Both 51 and 39 can be reduced again by a common factor. That factor is 3. So if I divide both the top and the bottom by 3, I will see that my fraction will reduce to 17 over 13. In number 3, I'm going to do this one using words. Trombones to trumpets. Trombones to trumpets. So 16 trombones to 40 trumpets is what it would look like using words. Both of these can again be reduced by 8, which is kind of convenient. So we end up with, whoops, sorry, I forgot we're doing words on this one. 2 to 5 would be the ratio in reduced form. And this last one I'm going to do using fractions again, because again, we're in math class. That's the most common way that we'll see it. Violins to total instruments. So violins are 24 to total instruments would mean the sum of all of our instruments, 40 plus 39 plus 24 plus 51 plus 16, which gives us 170. In fraction form, if we reduce that, both numbers can be divisible by 2. We end up with 12 over 85 for a final answer comparing the number of violins to the total number of instruments. and that is a ratio. An extended ratio is just a comparison, it's still a ratio, this time of 3 or more quantities. Extended ratios are written as the same way as we wrote other ratios, we just add numbers or terms to it. Okay, going to Okay, so those problems that I just skipped over, we are not going to cover in this class this year, so you don't have to worry about them. Okay, so now we're going to move on to proportions. A proportion is just an equation, meaning something with an equal sign, that states two ratios or fractions are equal to each other. So they look like this, two equivalent fractions. To solve them, we're always going to cross multiply, which means multiply the top left by the bottom right, so A times D, and the bottom left to the top right. So when we cross multiply here to solve, we get 4 times 7 is equal to 2 times x, or 28 is equal to 2x. At this point, I hope we know that to solve that, we would just divide by the number in front of the x on both sides, and we would get x is equal to 14. Similarly here, when we cross multiply and we get 19 times 12 is equal to 10 times x. And then we simplify this and we see that 19 times 12 is 228. 10 times x is just 10x. And again, we would solve that by dividing by 10 on both sides. So x is equal to 22.8. So that is the basics of solving a proportion. They do get slightly more complex, particularly if we have two terms in our with our x. We call this a binomial. Two terms, a term is anything that's separated by a plus or a minus sign. It doesn't seem like it, but the fraction bar is actually acting as a grouping symbol. So when we cross multiply in this case, we need to make sure that we apply distributive property. Okay. So 6 times 13 is how I got the 78. And we need to make sure that we distribute that number on the outside. Whoops, 78. So now when I solve this equation, it's a two-step equation. I have to add the 19 to both sides. I got ahead of myself and I put the 97 first, and then divide by 19, just like we were doing before. So we get x is roughly 5.1. We'll solve number 14 the exact same way. Again, applying distributive property. 19 times 17 gives us 323. And we subtract 20 from both sides, which gives us 5x is equal to 303, and then divide by 5 on both sides, which gives us x is 60.6. Okay, we're going to do a couple more, and then we're going to move on. Okay, so again, we'll cross multiply here. 10 times 9 gives us 90. 20 goes on the outside, 2x minus 9 goes inside parentheses, so we make sure we apply distributive property. So we get 90 is equal to 40x minus 180, sorry. We would add 180 to both sides, which would give us 40x is equal to 270, and then divide by 40 on both sides, so x is equal to 6.75. All right, I'd like you guys to try number 16. Pause the video and see if you come up with the same answer. Did you get x is equal to 2? Hopefully. If not, check your work, compare it with what's up on the screen, and see where you went astray. Okay, two final types of problems. If you look at number 17 and number 18, the difference is now we have two x terms in our proportion. So we just need to apply distributive property twice in these cases. So we would have 18 times x minus 20 inside parentheses is equal to 3 times x minus 11. And again, just distribute twice, which would give us 18x minus 360 is equal to 3x minus 33. To solve this equation, we need to get all of our variables on one side and our numbers on the other. So I'm going to subtract 3 x's from both sides, which gives me 15x on the left. And since I want my x's on the left and my numbers on the right, I'm going to add 360 to both sides, which is going to give me 327 now on the right. And the last step would be to divide by 15 on both sides, which gives me 21.8. We will solve number 18 the same way by applying distributive property to both sets of binomials. So we get 18x plus 18 is equal to 7x plus 16 times 7 is 112. Want to make sure we get that math right. Again, variables on the left, numbers on the right gives me 11x is equal to 94. And when we divide by 11 on both sides to get x by itself, we get x is equal to 8.5. Okay. These last two problems, similarly to the other ones that we skipped, are more advanced, and we're not going to get to them this year in class. If you're curious, you can always ask during office hours or something like that. But otherwise, we're going to move on. Okay, so our lesson for the day is really mostly on polygons. The other stuff was actually, believe it or not, all a review from middle school. So the idea of similarity is that polygons or shapes can have the same basic shape but different sizes. So like small, medium, and large versions of things. Polygons are similar if they have corresponding angles that are congruent and corresponding sides that are proportional. So proportional meaning equal fractions to each other. This is the symbol for proportional if you ever want to use that instead. The ratio of corresponding sides is called the scale factor, and sometimes you'll also hear it referred to as the similarity ratio. If polygons are similar, then their perimeters, which are made up of their side lengths, are also proportional. Okay, so let's talk about scale factor. The scale factor of triangle ABC, which is the smaller one, to triangle DEF, all we need to do is compare our matching sides. And we can get those matching sides, in this case, either from the picture or from our similarity statement. So ABC, side AB matches with side DE. We could also use side BC, which corresponds to side EF, or we could use side AC, which corresponds to side DF. Either one, as long as we make sure that they're matched up, we should see that they all reduce to 2/3. This is what it means to be proportional, equal fractions. So fractions that are worth the same amount, they have the same value, but they look different because the numbers are either bigger or smaller. Okay, order matters when it comes with scale factor, when it comes to scale factor. So here we compared the small triangle to the big triangle. In this case, if we compare the big triangle to the small triangle, our scale factor will be the same, but opposite or reciprocal. So since the big triangle comes first, then the big number is on top now in this case. And of course, the ratio of the perimeters of the big triangle to the small triangle will be the same as the scale factor because the perimeter is just made up of the side lengths. This is the symbol for similar. And so to write a similarity statement for the triangles above, the same way we did a congruency statement, we'll just use a similar symbol. It's like congruency, but without the equal sign. And we just need to match up our corresponding parts exactly the way we did. That is the conclusion of the first part of the video. To go over the remaining questions from the notes, please see part 2 of this video.